In part 2 of Mod 4b, we are going to be looking at rational exponents. And a rational exponent is an exponent that's in fractional form. When you have a rational exponent, the denominator is the index, which means the root that's being taken, and the numerator is the power. The definition of how to use a rational exponent is that if you have x being raised to the a over b power, you have two choices of how you can write it. You can write it as the b root of x to the a, or the b root of x that's being raised to the a. The second version is generally the easier version, especially when you are dealing with numbers and not just variables. First, we are just going to practice converting from radical form to exponential form. When we have the cube root of 7, and we want to write that in exponential form, first of all, our base is what number is in the radical. That's a 7. The numerator is the power on the 7. Since there is no power showing, we know that that's a 1. The denominator is the root that's being taken, which is 3. So the cube root of 7 is equal to 7 to the 1/3 power. For our next example, we have the 5th root of x to the 3rd. Our base is what's inside the radical, which is the x. The numerator is the power on x, which is 3. The denominator is the root we are taking, which is 5. Our last example for converting from a radical to a power is the square root of y to the 7th. So on this, our base is what's inside the radical, the y. Our numerator is the power on the y, which is 7, over what root are we taking? That's a square root because there's no number showing, so it's over 2. For our next set of problems, we're going to go the other way. We're going to convert from exponential form to radical form. We have b to the 5/4 power. So remember that the root you are taking is the denominator, so it will be the 4th root. Your radicand is what is the base of the exponent, so ours will be b, and then the power is the numerator. So b to the 5/4 becomes the 4th root of b to the 5th. Remember that we have a second way that we can write this. It stays the 4th root. The b stays inside the radical, but you can raise the entire root to the 5th power. For our second example, we have w to the 7/6 power. So this would become the 6th root of w to the 7th power, or it would become the 6th root of w, the entire thing being raised to the 7th. The only thing different about our last example is that our base is a number instead of a variable. The process does not change. So this could be written as the cube root of 5 to the 4th, or the cube root of 5, the entire thing, to the 4th. When you are evaluating an expression containing a rational exponent, it is usually much easier to find the root first and then raise to the power. Remember, you cannot take an even root of a negative base. We are going to practice evaluating rational powered expressions. Our first problem is 625 to the 1/4. Remember that the denominator tells us that we are doing a 4th root of 625. The numerator tells us the power is 1. The 4th root of 625 is 5 to the 1st, which is just 5. When you have negative 125 to the 1/3 power, you need to recognize that when the negative is out front like this, it is not within a set of parentheses. This is telling you to do the negative of, and then do the root and power of the number. Because it's a denominator 3, we are doing a cube root of 125, and we are raising that whole thing to the first power. Keep your negative sign. The cube root of 125 is 5. We're raising that to the first. Well, that's just going to be negative 5. On the next example, we have negative 64 in a parentheses. So this one is telling us to keep the negative 64 and do the fourth root of that, and then raise it to the first. We cannot do an even numbered root of a negative number. So this one is not real. Because the negative is not inside parentheses, this problem is telling us to keep the negative out front. A 1/2 power is a square root to the first. So we are doing the square root of 81. Well, the square root of 81 is 9, so our final answer will be negative 9. Next, we're doing 32 to the 2/5 power. This means that we are doing the 5th root of 32 and then squaring it. The 5th root of 32 is 2 that we are squaring, and 2 squared is 4. For our last example of this type, we are doing 16 to the 3/2. This problem then is the square root of 16 that we are going to cube. The square root of 16 is 4, and we're going to raise that to the 3rd power. 4 to the 3rd power is 64. The rules we learned earlier for exponents hold true when you are working with rational exponents. When the exponent is negative, rewrite the base using the reciprocal, and then change the power to positive. When you're raising a fraction to an exponent, take both the numerator and the denominator to that power. When multiplying bases, add the powers. When dividing bases, subtract the powers. When raising a power to a power, multiply the powers. We're going to put these exponent rules into practice now on rational expressions and rational exponents. Our first one, we have 1/16 raised to the 5/4 power. That means that you need to take the 4th root of 1/16 and raise it to the 5th power. Well, the 4th root of 1 is 1. The 4th root of 16 is 2. Now we need to take 1/2 and raise it to the 5th. 1 to the 5th is 1. 2 to the 5th is 32. Our next example, we have 625 to the negative 3/4. The reciprocal of 625 is 1/625. And then we are raising that, now that we used the reciprocal, to the positive 3/4. So now we are doing the 4th root of 1/625 and raising it to the 3rd. The 4th root of 1 is 1. The 4th root of 625 is 5. So we're doing 1/5 to the 3rd power. 1 to the 3rd is 1. 5 to the 3rd is 125. For 1/4 to the negative 5/2, because our power is negative, we start by writing the reciprocal of the base 1/4, and the reciprocal is 4. Once you do that, the power becomes positive 5 over 2. Since the denominator is 2, we are doing a square root of 4 that we are raising to the 5th. The square root of 4 is 2 to the 5th, which is 32. We're going to start simplifying by using the rules of exponents. And in our first problem, we have the multiplication of u to the 2/5 times u to the 1/5. When you are multiplying bases, you add the exponents. These exponents have common denominators, so this simply becomes u to the 2/5 plus 1/5, which becomes u to the 3/5. For this example, we are still multiplying the bases, which means we need to add the fractions, but 3/4 and 1/7 do not have common denominators. Common denominator for 4 and 7 is going to be 28. So the first fraction, we're going to multiply top and bottom by 7 and wind up with y to the 21 over 28 times, for the second power, the fraction needs to be multiplied top and bottom by 4. That will become 4 over 28. Now add your exponents and you will get y to the 25 over 28. When your bases are being divided, remember that the rule is that you subtract the powers. So a to the 5/8 divided by a to the 3/8 becomes a to the 5/8 minus 3/8, which is a to the 2/8, which we can simplify to be a to the 1/4. When we are doing x to the 4/3 divided by x to the 3/4, we do not have a common denominator. First thing we have to do is find a common denominator, and the common denominator for 3 and 4 is 12. That means that the power on the top needs to be multiplied by 4, top and bottom. So it will become x to the 16 over 12. For the power in the denominator, to make that into a 12, we need to take it times 3. So we're going to have x to the 9/12. Now the rule for dividing the bases is subtract the exponents. So we will have x to the 16 minus 9 is 7 over 12. For x to the 1/2 over x to the 5/6, the common denominator of those two fractions will be 6. So for the fractional power in the numerator, we need to multiply by 3, and it becomes 3 over 6. The power in the denominator is already a 6, so we're going to leave it as 5 over 6. The rule for exponents says that when you are dividing the bases, you subtract the exponents. So we're going to have x take 3 over 6 minus 5 over 6. You get negative 2 over 6. But that simplifies to become negative 1 over 3. We don't leave negative powers in our answer. Write the base as its reciprocal. The reciprocal of x is 1 over x. Now your power becomes positive 1/3. 1 to any power is just 1, so 1 to the 1/3 equals 1. X to the 1/3 we can't simplify, so it stays x to the 1/3. When you are solving equations that contain a square root, you square both sides of the equation and solve the resulting equation. Make sure that the radical is isolated on one side and all the other terms are on the other side. You must check your solutions to make sure they will work in the original equation. There are frequently solutions that do not work. These are called extraneous solutions. For our first example, of radical equations, we have the square root of the quantity x plus 10 equals 4. Notice that the square root is all by itself on the left side. So we can immediately start by squaring both sides of this equation. When you square a square root, they offset each other, and you are left with just the radicand, the what's inside part. So our left side of our equation becomes x plus 10. 4 squared is 16. Now we have a little algebraic equation to solve. We're going to subtract 10 on both sides, and we get x equals 6. We must check our solution. So I'm going to go over to the side here and check this. If I put 6 in my original equation, I will have the square root of 6 plus 10 equals 4. That gives me the square root of 16 equals 4. Is that true? Yes, it is. So we get to keep our solution. For our next example, we have negative 3 plus the square root of the quantity v minus 9 equals 4. Notice that the radical is not alone. It's not isolated. It's got that negative 3 on the front. The first thing that we have to do is add the 3 and get the radical by itself. So now we have the square root of v minus 9 equals 7. Once the radical is alone, you square both sides. Squaring a radical leaves you with just the inside. V minus 9 equals 7 squared is 49. Add 9 to both sides, and we get v equals 58. Let's check our answer. We will have negative 3 plus the square root of 58 minus 9 equals 4. We would have negative 3 plus the square root of 49 equals 4. Negative 3 plus 7 equals 4. Is this true? Yes. So we keep our solution. On this next problem, our radical is not by itself. We're going to start out by subtracting 6 on both sides. This leaves us with the square root of y plus 4 equals negative 4. When you get a situation like this, where you have something inside a radical equaling a negative number, that is not possible. That is called no real solution. When you have a radical symbol, what you have to remember is that that is always asking you for what's called the principal root or the positive root. So if you get a radical equals a negative, you stop right there and write no real solution, and you are done. On the next one, we have the square root of 5w plus 6 equals w. Our radical is already isolated by itself. We can go straight to squaring. So when we square this, we're going to have the square root of 5w plus 6 that we are squaring equals w that we are squaring. Remember that squaring a square root, they offset each other. And you are now left with just the radicand, 5w plus 6, equals w squared. What you have to recognize on a problem like this one is that now you have a quadratic, so you have to set it equal to 0 and solve it. We're going to subtract 5w and subtract 6 on both sides. This gives us 0 equals w squared minus 5w minus 6. We're going to solve this by factoring. This becomes w minus 6 times w plus 1. Set each of those factors equal to 0, and you get solutions of 6 and negative 1. Here's where you are frequently going to see extraneous solutions, so you must check these. So for our check, we would have the square root of 5 times 6 plus 6 equals 6. We would have the square root of 30 plus 6 equals 6. Square root of 36 equals 6. That's true. So we get to keep the solution of 6. Now let's try the negative 1. Square root of 5 times negative 1 plus 6 equals negative 1. I can stop right now because I know that if I have a square root symbol, I have to have a positive solution, and this is a negative. So this one does not work, which means w equals negative 1 is an extraneous solution, and we only have the solution of w equals 6. 6. For the square root of 5x minus 16 equals the quantity x minus 2, our square root is already isolated on the left. We can go straight to squaring both sides. Squaring the radical on the left is nothing new. What's different on the right is that we are squaring the quantity x minus 2, which is going to require that we use FOIL. So on the left, our square root and square offset each other. We are left with 5x minus 16. Squaring x minus 2 gives us x squared minus 4x plus 4. Now we have a quadratic equation because we have an x squared, which means we want everything equal to 0 on one side of the equation. Because my squared is already positive, I want to leave it where it is. I'm going to move the 5x and the 16 over to the right side of the equation. This gives me 0 equals x squared minus 9x plus 20. That factors into x minus 5 times x minus 4. Set each factor equal to 0, and you get solutions of 5 and 4. Remember, you must check solutions. If we put 5 into that original problem, we will have the square root of 25 minus 16 equals 5 minus 2. 25 minus 16 gives us the square root of 9 equals 3. That's true. Going to the solution of 4. Putting it in the original problem, we would have the square root of 20 minus 16 equals 4 minus 2. Square root of 4 equals 2. That also is true. We get to keep both solutions on this problem. For the problem of the square root of negative 5a plus 21 equals the quantity a minus 3, our radical is already isolated, so we are going to begin by squaring both sides. And again, on the right side, we are squaring a binomial, which is going to require FOIL. So the square root and square offset each other, we are left with our radicand of negative 5a plus 21 equals a squared minus 6a plus 9 when we square a minus 3. We have a square on the right side that's positive, so we're going to move the terms from the left to the right to get our 0. This will give us 0 equals a squared minus a minus 12. This factors into a minus 4 times a plus 3. Setting each factor equal to 0 will give us solutions of a equals 4 and a equals negative 3. We must check both solutions. If we put 4 into that original radical, we will have negative 20 plus 21 in the radical equals 4 minus 3 on the right. This will give us the square root of 1 equals 1. This is true. That means we get to keep a equals 4. For the negative 3, we would have the square root of positive 15 plus 21 equals negative 3 minus 3. This would be the square root of 36 equals negative 6. When you have a square root symbol, it cannot equal a negative number. So this solution does not work, and we must throw out a equals negative 3.